Hello everyone, welcome to E240 Power Engineering Lab. Today we are going to demonstrate open circuit and short circuit test on single phase transformer. Now let's see the single phase auto transformer having the high voltage winding and low voltage winding. The rating of high voltage winding is 230 volt 50 Hz 9 ampere, whereas for the low voltage winding 115 volt 50 Hz and 17.4 ampere. This is the MCB to turn on and turn off the transformer, and then there is a LED which shows the on and off of the transformer. After that there is a display which shows the output voltage, that is low voltage side voltage, and then there is a fuse. You can see the fuse. Now I will open the fuse. This is the rating of the fuse, 500 volt and 80 kiloampere, which is used to protect the transformer from surge current. Now what we will do, we will see the inside structure of the transformer. So this is the inside structure of the transformer. You can see this is the laminated core, and then after that there is a winding. Primary side winding and secondary side winding are wounded on this core. You can see these are the winding. This is primary side or 230 volt side. This is a secondary side or 115 volt side. Now I will show another transformer which is similar to it. So this is a transformer having the rating of 500 VA. Now this and this structure are same. So you can see these are the 500 VA transformer having prime two sides, 115 and 115. This is laminated core, and these are the winding of the transformer of primary side and secondary side. This is a wattmeter. You can see there is a display where you can see voltage, current and power factor. There are the some knobs which by using you can calculate voltage, current, power and power factor, active and reactive power. Now let's see the back connections. C, L, M, V, C. Whereas L is a load side, M is main side, and between V and C there is a pressure coil to measure the voltage across the circuit, whereas between L and M there is a current coil which is used to measure the current flowing to the circuit. Now what we will do, in main side we will give the supply, whereas for the load side we will connect the transformer. Now let's see the internal connection of auto transformer. This is auto transformer where is out rating of the auto transformer is 10 ampere and 270 volt, and this is the inside structure of auto transformer. You can see this is a toroidal winding, and now this is the knob where we will increase the knob. As we increase the knob, voltage will increase. Now this knob is there, so voltage is 0, means this output voltage is 0. Now as we increase the knob, the output voltage start increasing between these two terminals. Now this is a 270 volt across the transformer. This is a circuit for the open circuit test. This is auto transformer. Then there is a ammeter. This is ammeter, and then wattmeter to measure the voltage, current and power drawn by the transformer. After that there is a voltmeter, and then transformer. It has high voltage winding and low voltage winding. The rating of low voltage winding is 115, whereas for the high voltage winding is 230 volt. We have connected supply to low voltage winding, and high voltage winding is open circuited. Then we will supply give supply to the low voltage winding using auto transformer, and we will measure the power drawn by the transformer. So let's turn on the circuit, and we will measure the current, voltage and power. Now I am increasing the voltage till rated voltage. The rating of the low voltage side is 115. So now I am increasing the voltage. You can see low voltage side voltage on voltmeter. I am increasing around 115. So you can see voltage increasing as I increasing the knob of the auto transformer. It's almost reached 115. It's 115. Now you can see current drawn by the transformer and voltage, applied voltage in wattmeter. So these are the voltage around 115 and the current in milliampere. You can see in open circuit test current drawn by the transformer is very less, it's around milliampere, whereas the power drawn by the transformer is around 13.685 watt. So using this reading you need to find out the open circuit parameter of the transformer, that is R0 and XM. Now we will do the short circuit test on the. Now we will do the short circuit test on transformer. This is the connection for the short circuit test. Auto transformer, then ammeter, wattmeter, voltmeter and transformer. In this circuit we have short circuited the low voltage winding using the conductor. You can see there is a conductor which is short circuited the low voltage winding, whereas for the high voltage winding we have given the supply. The rating of current rating of the high voltage side is 9 ampere, whereas for the low voltage winding is 17.4 ampere. So we will increase the voltage such that current will reach around 9 ampere. So let's turn on the circuit and using auto transformer we will increase the current till 9 ampere. So now I am increasing the voltage of the auto transformer, and now you can see the current also increasing. So this is the current, it's almost 9 ampere, because we have to do the short circuit test on rated ampere. So this is 9 ampere, this is rated current, and this is the primary side or high voltage side applied voltage. Now you can see these are the reading of the wattmeter, voltage, current and power drawn by the wattmeter. Voltage around 12.79, whereas current is almost 9 ampere and power is 109.37. So using this reading you have to find out the short circuit parameter of the transformer, that is series resistance and inductor of the transformer. Now we will see the current drawn by the transformer and its waveform in open circuit and short circuit test. For open circuit set, this is auto transformer connected to low voltage winding, whereas high voltage winding kept open. Now what we will do, we will vary the voltage using auto transformer. So now you can see I am varying the voltage till 45 volt, and you can see the current drawn by the transformer on the CRO display. So now you can see as I increase the voltage, current is nearly sinusoidal. So we will go on vary around 40 or 45 volt. So you can see the current drawn by the transformer around 45 volt. So you can see current is almost sinusoidal. Now I will increase voltage till 80 or 85 volt, and after that we will see with what will the effect of the uh, what will the effect of voltage on the current waveform. Now I have almost increased 82 volt. Now you can see the current waveform, it is slightly distorted. Now I will increase the voltage till rated voltage around 115. So now I can see as I increasing the voltage, the current waveform get distorted. So you can see I have reached almost 115 volt, that is rated voltage of low voltage side, and you can see the current drawn by the transformer is distorted. So we will leave this exercise to you, find it out why, what would be the reason behind the this type of waveform. In similar way, we will observe the behavior of current in short circuit test. You can see this is auto transformer connected to high voltage side and low voltage side is short circuited. Now what we will do, we will increase the current using auto transformer till rated ampere, that is 9 ampere. So let's increase the voltage by using auto transformer. Now you can see the current waveform and current magnitude. So now I will increase the current. Now you can see the current waveform, it's nearly sinusoidal. As I am increasing the current also, the waveform remains sinusoidal. In previous case it was not sinusoidal, but now you can see till 9 ampere means rated current is sinusoidal. We almost reached around rated ampere. Now you have to find out what could be the possible reason for this behavior, that in short circuit it is sinusoidal but in open circuit it is distorted.